All right, second part of our lesson for November 5th here. I forgot to mention in the previous one that we have like a way or a method to help us two-dimensionally illustrate these magnetic fields, right? Because it's a three-dimensional magnetic field. It could go left, right, up, down, or what we say is into or out of the page, right? So if I have this current right here, it's got these loops around it. The wire does, right? And these loops or concentric circles are what illustrates the magnetic field. So it's very difficult to draw this, and even more difficult to have an understanding of what's going on by taking a look at that picture, right? Because there's different things that are happening on each side of this wire. So in other words, look at it. What's the magnetic field that is associated with this current carrying rod? Well, it's concentric circles that are around this wire. Well, the only way to get my hand around this two-dimensional wire that's written on the board is if I went into the board above the wire, wrapped my hand around this wire behind the board, and then came out of the board below the wire. So the lingo that is used, or the nomenclature, says that this field is into the page or board above the wire and out of the page below the wire. Now, that means in front of the wire we're going up, and behind the wire we're going down, but we can't really write that on the page. So instead, we say into the board up here, out of the board down here. So into the board up here, out of the board down here. Now even that gets kind of tedious. So we have symbols. Into the board is symbolized by an X, and out of the board is symbolized by a dot. So if we come over here and we say, okay, here's this current carrying wire, the current is going up, which means I have to wrap my fingers around my right hand around the wire. Well, the only way I can do that is to go into the board over here on the right. Well, X's are symbols of into the board. I wrap it around, and there's dots over here on the left side. What's that mean? The field is into the board here. I go behind the wire. I'd be over here, this way, in this direction. And then I wrap my fingers around. So on the left side of the wire here, the field would be coming out of the board. Now again, don't forget that all these symbols are really telling us what happens with this compass. So if I put the compass over here, it would be pointed into the board. And if I put the compass over here, it would be pointed out of the board. Because the compass is really always the default for the direction of our magnetic field. All right, now one last try here. So let's say we've got a current carrying wire here. And let's have the current go this way. All right, well, how would I use my right hand rule? I would take my thumb and I'd point it in the direction of the current. I'd have to try to wrap my fingers around this wire. Wrap my fingers around the wire. The only way to do that if my thumb is pointing this way is to go into the board down here, wrap around behind, and come out of the board up top. So I would be into the board here, out of the board here. Now, of course, on each of these things, the field runs infinitely far away. So there's still a field into the board way out here. Obviously, the field is getting smaller, 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 smaller because we're getting farther away. Usually then, we just symbolize it with dots and X's right next to the wire. Into the board, out of the board.